This is actually my first talk at a conference or to an external audience, so I'm sorry. I'm David Danzilio. I'm a systems engineer and puppet evangelist at Constant Contact. My background is sort of a hodgepodge of web, healthcare, higher education, nuclear weapons research, and I'm deadly serious about that. I've been using Puppet for a long time, longer than I'd like to admit. And I've seen a lot of really interesting implementations. I've seen some good implementations, a lot more of the interesting ones than the good ones. When I responded to the call for presentations, I wanted to put together, a list of things that might be helpful to know when you're starting out with Puppet. So that's what this is all about. It's a collection of wisdom that I wish I had available when I first started using Puppet. A lot of this stuff wasn't possible back then, but if I was starting right now, this is the kind of stuff I'd like to know. The documentation has gotten a lot better these days, and it's a lot easier to get started. But there's just so much information out there. It takes a lot of effort to aggregate and synthesize it. So the goal of this presentation is to distill some of the best practices that are good to know up front, and hopefully it'll make it a little easier for you to get going. That being said, I think that a lot of this stuff in this presentation is good for newcomers and old-timers alike. When I was writing this, I sent the presentation out to some colleagues, and a lot of them came back and said, I wish I could get my team to come to this presentation and do this, because it's really hard to, especially for people who started using it a long time ago, it's really hard to instill good behaviors. I guess old habits die hard. So a couple of warnings. This could change in future releases. The language is rapidly evolving, but in this presentation focuses a good bit on module development, because it's such a huge part of a successful Puppet deployment. It doesn't really matter how well you scale your Puppet masters if your modules are just awful. It's important to keep in mind that the Puppet ecosystem is rapidly evolving, so some of this could change. Don't just take my word for it. I'm not the only one talking about this stuff. This is really an aggregation of best practices. So when you get home, the slides should be posted fairly quickly. Go take a look at some of the content in the further reading section. And I think a huge part of this presentation should be to get you thinking. And you may not understand all of the concepts as I present them, but definitely go back through the slides when you get home and see, maybe I should look into some of this stuff. So, and it is my opinion. I like to think that my opinion is particularly well informed in this sphere, but so it is take it with a grain of salt. Some of this stuff may not work in your environment. I'd be really interested to see your environment if that's the case, but I called it Greenfield Puppet because Greenfield is a project that lacks any constraints imposed by prior work. So, and the call for proposal said that like half of Puppet Camp attendees are just starting out with Puppet. So it's possible that at least some of you are working on a Greenfield implementation. Keep this presentation with you. And just in case you don't know, that this is what a Greenfield project is. You get to let the requirements dictate without having to work around somebody else's bullshit. And this is sort of how am I going to This is sort of what I want your Puppet implementation to look like. Hopefully this presentation will help your Puppet implementation look a lot more like New York City than it does Boston.
So you have a problem with Boston?
I love Boston. Boston is my home. So I figured we should start with sort of a not so hypothetical scenario. This is Joe. Joe's trying to pay his way through grad school by working as a systems administrator in the basket weaving department of Fu University. And the department just developed a Rails app, and they need Joe to deploy it to like 100 virtual machines. So he knows he's going to need to install Rails, Passenger, Apache, and it's all going to be on top of Ubuntu. And this is Joe's first big project, so he knows he's not going to be able to do it by hand. So he decides to try out this Puppet stuff he's been reading a lot about. So he follows some documentation to get a Puppet master up and running, get the agents installed, and then he sets out to write a module to deploy his application. So this is what he writes. This is not good code. Just nobody use this. Joe writes an Apache module to install Apache, Rails, and Passenger, and place a configuration file, and deploy his application, and start the Apache service. It sounds great. It works great, even. He installs his module in the Puppet master, includes it in his nodes, runs Puppet, and within minutes, he's got his application deployed to all 100 servers. His boss is thrilled, and he celebrates with a beer. Until Dr. Strangelove comes by the next day, and Dr. Strangelove is apparently the preeminent scholar in the field of basket weaving. So he tells Joe he's decided to use Graphite for all his basket data. So he needs Joe to build him an instance of Graphite. But, Joe is too busy to write a module for Graphite. He doesn't really know Graphite all that well. So he decides to check out the Puppet Forge, see if there's already a module he can use. And he finds one from a reputable author with a lot of downloads. And everything looks good until he goes and takes a look at the dependencies tab, and he sees that a dependency is an Apache module. And he's thinking, I just wrote an Apache module. I'm going to have to rewrite it. Or I'm going to have to write my own Graphite module. So he takes another look at his code, and he realizes that his Apache module is not really even all that modular. It's too specific and too broad. His Apache module isn't even really about Apache, it's about the basket weaving app. Joe sort of forgot the Unix philosophy. And I'm sorry to the Windows folks in here, I sort of forget sometimes that Puppet is expanding their offering in the Windows ecosystem. But this is good advice for anybody. Doug McElroy is a foundational Unix developer, and he famously described the Unix philosophy to write programs that do one thing and do one thing well, and to write programs that work together. So Joe's module does too many things by installing the unrelated packages and deploying his application, and his Apache module doesn't even let him configure Apache, right? And this pattern is something that I've seen in a lot of different environments. So it sounds like a silly example, but it's really not. So let's talk about how we could have avoided this. So we'll start out with modules. The first rule of module writing is don't write them. Why write a module when there's probably already one out there that you can use? The Forge should be your first stop shop when looking for a module. This is the number of modules that were on there as of Sunday afternoon, 2,617. I'm pretty sure that a lot of stuff that you're going to want to run in your environment is available as a Puppet module. But if the module doesn't do exactly what you want, don't customize it. Maybe you found a module that does kind of what you're looking to do, but it doesn't do everything you want. Maybe you want a MySQL module, but you want it to include Nagios checks or something like that. So your first inclination is to download it and add functionality that's missing. Resist that inclination, because modifying a Forge module forces you to take ownership of the module's lifecycle. And once you modify it, you can't take advantage of upstream changes. You don't really need to always modify a model to add functionality, and this is where roles and profiles can help. So I'm talking a little bit about roles and profiles. I'm not going to go into depth on it, but I'll sort of introduce some of the concepts. Craig Dunn first sort of articulated the roles and profiles pattern in a blog post. There's a link to it in the further reading section. So it basically goes like this. A node includes one role and only one role. And a role describes what a server should look like from end to end. So this is, there are two nodes here and they both have different roles. I got a DB server role and a DB server dev role. And then a role includes one or more profiles. And so here are those two modules with the base role, because it inherits those. So your environment can be broken up into roles. I've heard a lot of people say, no, it can't. I've got too many edge cases. No, edge cases are roles. So you'll see here, my DB server role here includes the MySQL profile and then an application database profile. But my DB server dev role includes MySQL and then Percona. And they all inherit the base class, so they have the base profile as well. And a profile manages modules. So a profile combines individual components to implement a technology stack. So here's the MySQL profile. You'll see I'm pulling some data in from Hiera. I'm including the MySQL server class and telling it what version of the package I want to use. And I'm including the MySQL backup because we like our databases to be backed up. And then I'm adding some Nagios checks with the Nagios MySQL module. So you'll see instead of forking the MySQL module and adding monitoring functionality, I've simply created a profile to wrap the MySQL module and add Nagios checks with my Nagios MySQL class. So you don't always have to modify a module to add functionality. It's sort of like model view controller for Puppet. Now that I've told you not to write your own modules, I have to talk about how to get them. So let's talk about how to effectively use the Puppet Forge. There are very few metrics available to judge the quality of a Forge module, but a good place to start is with the number of downloads and the frequency of updates. So you'll see here I'm looking for a memcache module. This one's got lots of downloads and a recent update, so I'd say that one's a pretty good one to go with. But you should also do some background research on the author of the module. Look at the author's other Forge modules. Take a look at her GitHub. Google the username. You're trying to gauge how reliable and how active the author is. If you can't glean much information from the author, don't be afraid to scrutinize the module. Does it have lots of downloads? What are the dependencies like? When was it last updated? Is it well documented? These are all good answers, or good questions to answer when pulling a module in from the Forge. Give priority to modules written by Puppet Labs. Puppet Labs modules are well maintained and have a solid development process. They're usually well documented and tested. These modules are often archetypes for good module development. So if you're looking for a particular module and Puppet Labs has written one that meets your needs, you should generally always go with the Puppet Labs version. So be wary of modules with strange dependencies. And I have an example, but I want to start by apologizing to the module's author. I'm not trying to pick on him, and I really debated whether or not to even include it. But I ultimately decided the example was necessary to illustrate my point. So Dennis here wrote a Nagios module, but he decided to use his own sudo module. But a long time ago, the community settled on SAS sudo as the standard bearer sudo module. It's like near universally accepted as the module of choice for managing sewers, and it's a dependency for like countless modules. So if I wanted to use Dennis's Nagios module, I'd have to rewrite it to support SAS sudo. So don't use modules with strange dependencies. It's a recipe for module conflicts, and it essentially forces people to change your modules if they want to use them. You look here, the SAS sudo has 49,000 downloads. Dennis's sudo module, which is a dependency for the Nagios module, has 22,000 or 2,200 downloads, but his Nagios module has 13,000 downloads. I don't know, there's some sort of disconnect there. But don't use a module without vetting it. You want to make sure the modules you're introducing in your environment don't do stupid shit, because there's bad programming everywhere. You also want to make sure that they don't contain malicious code. So never use a module without understanding exactly what it does. We'll talk a little bit about Puppet deployment, but Puppet deployment can be pretty tricky because it depends heavily on your requirements. But I've put some tips in here that can make it a little bit easier. Have a solid deployment pipeline. Ensure that your deployment pipeline is well-defined and understood. Make sure your pipeline is the only way for a module to make it into your environment. If you're not using continuous integration, you should be. If only for Ryan Gosling here. Use Library and Puppet or RTNK to deploy your Puppet code to your masters. Library and Puppet and RTNK are great tools that can help you manage your Puppet modules, sort of in the same way that Bundler manages Ruby gems. This can help enforce your workflow and keep your deployment pipeline clear. Reliable metadata is key to a successful Puppet deployment. This slide made it into the presentation fairly recently as I was struggling with this problem at work. I'll repeat that. Reliable metadata is essential to a robust Puppet implementation. How do you know, what a node is after it's been provisioned? You need to be able to classify your nodes and group them by functions or roles or by whatever your environment pivots on. So make sure that you place metadata early in the lifecycle of a node, and make sure that the metadata is always up to date. Here's an example of some metadata that you can place at provisioning time. Just pop a file in etc factor facts.d, and Factor will make it available during your Puppet run as facts. I'm sorry, I don't know where to put this on Windows, but use environments to keep your nodes safe.
/program data, Puppet Labs, Puppet, etc.
Excellent, thank you. This sort of sounds simple to some people. Use environments to keep your nodes safe, but I know a lot of people who only have one environment and their nodes aren't very safe. So you should have a Puppet environment for each of your deployment environments. And at the very least, you should have like a production environment, a stage environment, and a development environment. Never push a module to production unless it's successfully deployed in the other environments. Understand the lifecycle of the module. This holds true for forge modules as well as custom modules. You want to understand how a module manages the resources on a system, and understand what happens when you want to stop using a module too. Use Hiera from the start. I saw like a depressing number of hands go up when Patrick asked about who was using Hiera. Hiera is a hierarchical key value store for Puppet, and it's essential for a successful Puppet deployment. It allows you to store your configuration data natively as plain text YAML or JSON files. So this means, like, unlike a traditional configuration management database, your data can be version controlled. So if you haven't delved into Hiera yet, you absolutely need to. And when you're designing your hierarchy, don't get too crazy. If your hierarchy looks like this, you've got a big problem. Keep your hierarchy simple. You want to focus on data deduplication, right? I mean, I guarantee that you don't need a hierarchy like this one, and this is real. I didn't make this up. So. I mean, if anybody thinks they're getting any sort of deduplication out of this, they're crazy. So now that I've told you not to write Puppet modules, let's talk about how to write Puppet modules. Because, all right, the first thing, Puppet code is real code. I'm sorry, but it's just a fact of life. Infrastructure as code has brought a bunch of people who never really considered themselves software developers into the development world. And it's important to remember that Puppet code is real code. And it needs to be treated like real code. So this means version control, release cycles, testing, documentation, so forth. And also, Puppet is Ruby. I really hate to dive into a religious war on this one, but it's important you understand that Puppet's written in Ruby. But I'm not really that sorry because all of the tooling around module development has grown up in the Ruby ecosystem, and as a result, Puppet module development ends up looking strikingly similar to Ruby development. So I would recommend that you cast aside any language dogma and dive into Ruby a bit. It'll make your approach, it'll make your life much easier, and in the end, it'll make your approach to Puppet code more robust and informed. Puppet modules need a design specification. The ugliest code is often the code that had no design and somebody just started writing. So when setting out to write a module, make sure that you think about what you want your module to accomplish. Write it down. That's an important step. You can use pseudocode to achieve this, or diagrams, or whatever helps you conceptualize your module. Focus on identifying functions, interfaces, and extension points of the module. This step will completely change how you implement it. Test-driven design or development, depending on who you ask, with RSpec Puppet is a great way to design your modules. It forces you to focus on what's important to you and results in minimalist designs and that foster reusability and modularity. It also forces you to write down a spec for your modules functionality, and this can be very powerful documentation. I think a good design principle is to design your modules with the assumption that someone else will be using it. This is a big shift for most sysadmins who are used to writing scripts to automate their own tasks. But how many times have you walked into an environment and spent an ungodly amount of time trying to deconstruct your predecessor's scripts? I know everybody in this room knows what I'm talking about. So designing with other people in mind will result in modules that have clean and well-defined interfaces, documentation, and validation. Fail fast. Your modules should know when to fail and should tell the user why it failed. Here's an example using the fail function, very aptly named. Instead of getting an error saying this package is not available, it'll tell you that this operating system is not supported by this module. So your module should provide descriptive error messages. Public classes should expose a stable API. Limit your module's entry points. Public classes are those entry points, and they're the interface to your module. So public classes should be where you validate inputs and call your private classes. But when designing a public class, remember that your parameters make up your module's API, which should be stable, feature-rich, and flexible. Semantic versioning is the standard. If you want to ship modules to the Forge, it's a hard requirement. Forge users expect to be able to rely on semantic versioning when downloading or updating a module. But the good thing is it's pretty easy. If you're not familiar with it, there are 3 components. There's major, minor, and patch. You increment your major version for breaking changes. So if you change your API and make a change that's not backwards compatible. You increment your minor version for new non-breaking functionality. So if you add new functionality that is backwards compatible. And then you increment your patch version for bug fixes. Remember the Unix philosophy. Focus on writing small modules that are designed to be interoperable. And when designing your modules, focus on doing one thing really well. Share your custom modules with the community. if you do end up writing a module, share it with the community. I mean, maybe your motivation for writing a module was that there was nothing out there that couldn't meet your needs, but I guarantee you're not the only one with similar requirements. So help somebody out, post it on the forge. And manage your dependencies with care. If you remember my strange dependencies example from a few minutes ago, don't force your users to rewrite your module because you made a bad call on a dependency. When deciding on dependencies for modules, make sure they're well-known modules and they're unlikely to conflict with others. Keep artifacts out of your Puppet modules. Don't use the Puppet file server to deploy code. For that matter, don't really use the Puppet file server for anything other than a configuration file. And absolutely avoid recursive file lookups. They're very resource intensive, and it's not fun when it brings down a Puppet master or an entire environment of agents. So, embedding data makes your modules less modular. Don't do it. You should use parameters to get data into your modules. You can put default data in a separate params class, but this should only be used to set sane defaults for your parameters. But always allow users to override your default data. So I've got a foo class, and I've exposed 2 parameters, and I've inherited the foo params class, and I am getting the default values for my parameters from their values in the params class. So in this example, anybody could use this module with their own custom packages without having to rewrite the module to override your data. And that pattern is good even with the impending Hiera data in modules stuff. You can only you want to be able to have some function. You want your people to be able to use your modules right out of the box. So I think that while the data in modules spec is supposed to do away with it, it can still be helpful for backwards compatibility. We'll talk a little bit about that in a minute. Definitely keep business logic out of templates. If your templates look like this, you have a problem. So here's a conditional that checks the value of the app parameter to determine what content to place. This will very quickly become a nightmare. I've seen templates like this that end up thousands of lines long, but end up parsing only to like 20 lines. So keep business logic out of your templates. Here's a way to move that business logic into the DSL. You just create separate templates and use a selector or something like that based on your app parameter. This isn't the best way to do it, but it's what would fit on the slide. So. The standard library. The standard library is amazing. I love the standard library, and if you don't love the standard library, you're wrong. The standard library really lets you write beautiful and feature-rich modules. Use it, absolutely. It provides all kinds of functionality. So it's a collection of functions and resources that can help you design modules. The ensure functions allow you to install packages and create resources that may already exist in the catalog without causing resource conflicts. These functions are good for ensuring that your modules don't conflict with others. So a good rule of thumb is to always use the ensure packages function when installing packages in a module. So like typically if you wanted to install Apache 2 in your module, you create a package resource and ensure present or whatever version. But if you do this, nobody else can list this package in their module because it would cause a resource conflict. So a way to avoid that is to use the ensure packages function. The ensure packages function takes a list of packages and only adds them to the catalog if they don't already exist. This way, more than one module can list a package as a dependency without causing a resource conflict. Validate your inputs. There's no excuse not to validate every single parameter in a public class. And the standard library is what lets you do that. You can validate against arrays, booleans, hashes. You can use a regex or a string. There are a bunch of others, and there you can use external commands and stuff like that. This allows your modules to fail fast when passed invalid data, and it gives your users a descriptive error message. Protect your private classes with private. Private classes are classes that shouldn't be invoked outside of your module. So by explicitly marking your classes as private, you can ensure that your module is being used in a way that it was designed, and it's behaving in a way that it was intended to behave. So don't expect people to follow the rules. You want to write modules that are opinionated but not overly rigid. So yeah, don't expect people to follow conventions. Modules should be easy to use and hard to abuse. It took me a while to come up with that. Your users should be able to use your module quickly and easily in their environment, but it should be hard for someone to use your module in a way that was not intended or in a way that could break it. I think that people sort of discount style, but I think it's substantive. Style is important because adhering to a consistent style helps ensure that everybody understands what's happening in the code. This is especially important if you're developing your modules in a distributed fashion. A lot of times style can take a backseat to urgency or efficiency or whatever, but I urge you to consider the cost of sifting through all kinds of lint the next time you're trying to fix or extend sloppy code. There are some good tools. Puppet-Lint's a great tool that can help you check your code's compliance with the style guide. You should add to a gem file the root of your project and create a git pre-commit hook to run the lint checks every time you try and commit a change. Puppet syntax isn't really a style helper, but it helps ensure that there aren't any syntax issues in your code. Puppet syntax doesn't actually compile your code, so it doesn't catch runtime errors like typo in a resource name or something like that, or in a resource title. But it does check to make sure that your code parses successfully. So here's an example gem file you can use. You can copy and paste this and get started today. You'll need to have Ruby gems, and bundler installed. And then here is a rake file to let you use the tasks that come with those gems. So you'll just place that stuff in your gem file and rake file, run bundle install to install the gems, and then here are the list of commands that are available to you. Bundle exec rake -t gives you that list. So I think that once people start using these tools in their workflow, they'll start to use other ones like RSpec Puppet and stuff like that. So. This is some common tooling for you. Documentation is important. It's important for you as a user and as a developer. How can you make changes to a module if you don't know what the module, what each of the parameters do? Why would you want to use a module that you have to reverse engineer in order to understand what the hell it's doing, right? So every module should have a README that gives an overview of the module, lists and describes all the public classes, including the parameters and variables. Your public classes should have inline documentation. The style guide explains a Puppet doc format. You should describe your parameters at the top of the file and stuff like that. Anybody who has a hookup at Puppet Labs that could give me some more information on the status of Puppet doc, that would be great. Because functionality has been a little lacking lately, so thanks. Here's an example. This is an NTP module. It has 114 lines of documentation in its main public class. This is beautiful. Here's a Docker module. 82 lines of documentation in its main public class. But notice, I don't have to go sifting and figure out what each of these parameters is going to do. It's great. We're all developers now. If you're using Puppet, you're a developer. And it's your job to learn some basic software development practices. like version control and code review and documentation and stuff like that. Keeping up with the community and the language can seem like a pretty daunting task at first because it's evolving so fast. But there's a fantastic community out there. So I would recommend that you pay attention to thought leaders. The community is filled with some really smart, committed, and outspoken people. Pay attention to them. Follow them on Twitter or dig through their GitHub accounts. Look at the modules they're writing. Imitation is the sincerest form of flattery. Also, take a look at who Puppet Labs is hiring because they do have a tendency to hire thought leaders. Puppet Labs has a great YouTube channel that has presentations from Puppet Camps and Puppet Comps. And I can't stress this fact enough. Make sure you're keeping an eye on the development of the language. It's much easier to gradually refactor your code as the language evolves than waiting and having to refactor everything at once in order to keep your environment up to date. This is why people are still using Puppet 2.7 right now. Refactor your language as the code evolves, refactor your code as the language evolves. You can keep track of Puppet development by taking a look at Hiera. This is a screenshot of the roadmap board. Don't fall behind. I'm speaking from experience on that one. And contribute to modules in the Forge. A good way to keep up is to get involved and the best way to get involved is really to become a contributor. So find a module that you use or that you like and contribute to it.
Or don't like.
Or don't like, exactly, yes. So I'm a little short, sorry about that, but any questions? We'll start over here. Make the line.
Does the Puppet syntax gen have a benefit over the Puppet validating?
No, it's essentially a wrapper, but it checks to see if Hiera data is valid YAML format and stuff like that. It's common tooling. It's easier to use.
And ERBs.
And ERBs, yeah. Back there.
Hi, I really like your talk, so thank you.
Thank you very much.
I understand what you said. My one sort of thing on the model dependency. So obviously, like the library and using dependencies. But at a certain point, when you want to build certain things, you might have the possibility that a name collision between something you write and something else is going to happen. So I think the baseball is the Puppet language doesn't want you to deal with that and say, vary a model name that's attached to your code. I think that's really the big issue, not necessarily.
Exactly. Yeah.
And that's really something I'd like to see fixed in Puppet, so that in the odd case when you have a Puppet something model, and someone else has a depth that doesn't flash, as it does the name, you could do that.
I would love to see that functionality as well. So, thank you. Do we have any other?
What's your best practice on Puppet masters as far as community requirements? Have one Puppet master requirements in it, have separate one production, one individual ones for each environment?
Okay, so the question was, what's the best practice for sort of segregating your environments? One Puppet master with a bunch of environments, or Puppet masters per environment. Did I sum it up?
Yep.
That's a very hard question to answer, and I think that this really is driven sort of by your requirements, also by your culture. Is your team going to be comfortable with automated deployments of code to your Puppet masters and stuff like that? Is your management confident with having multiple environments on one box? Also, I've worked in government, so classifications, stuff like that. Having different security levels that's a very hard one to answer, and I really can't say one's better than the other. And I've done it both ways. So.
Yeah, that's a good question. I will hear from you those. Probably the DoD compliancy, so is any of the other engines that is compliant first of all, or any of these other CFMs DoD compliant?
That's a very good question. I work for DOE, so I don't know off the top of my head, but I'm sure some might be able to answer that question for you. So.
There were some NIST standards, modules published for hardware. So I think CFI or CII standards. There's some modules that were published by NIST, and I think.
I'm sorry, the question was what elements of Puppet, like Puppet DB and stuff like that,
Could be, or just as public in general.
are
Just as
like DoD certified and stuff like that.
I've had that question before. I need no other CMS.
That's a good question. Yeah. Anybody else?
You mentioned something about checking the modules for religious schools. Obviously, this is no-brainer. But as the I guess the certification becoming the norm, a lot of times requires static and dynamic scanning. Do you recommend a particular software that actually help with static scanning for Puppet or Ruby or language as a language?
I can't. No, I'm sorry.
You can use one, but Ruby is not supported.
Oh, okay, yeah. Over here?
We have an existing Puppet environment, and we're setting up a new infrastructure with a new Puppet environment. And one of the things we're wrestling with is finding the right balance between trying to figure out everything ahead of time, hierarchy, the roles, protocols, specifications, versus wanting to put some pieces up and get it working. What do you comment on that?
So the question was, I guess, how much planning to do, I guess, sort of.
Finding the right balance between planning ahead of time and deploying pieces of time and passing.
Yeah, right. So what's the balance between planning ahead of time and sort of the stuff that you're really only going to learn through trial and error? I think that, with Vagrant and stuff like that, there's, you can do a lot of that discovery without having to devote a lot of resources to it. So I'm actually standing up a new environment right now myself, and the first thing I did was stand up a Puppet Master. So I would still put that in the planning category because there are, and especially in my case, I only know like a handful of other people using Puppet at the scale that we are. So a lot of stuff I'm gonna have to figure out for myself. So I'd say plan as well as you can, but definitely be amenable to changing your plan.
That's why stat in this. That's why things like CI are so important in this, kind of natural development methods around your process.
Yeah.
So definitely try to align with the other development and engineering teams from a process perspective. It'll help the entire organization if everybody's on the same sort of mantra and cadence, even on their operational development cycles.
So it looks like I'm out of time. Thank you. I had a lot of fun. If you have other questions, come see me.